begin. So where we left off, I just brushed through the rules and best practice file here. It is in the package, so you can look at it if you haven't already. And from here on, we're moving on to sourcing parts. Now, for this session, we'll start with the Blinker SCH-1 project folder here. You can open it up from the project folder there. And when you open it, it should be essentially where we left off last time. I'll give you guys a bit of time. Schematic -1, so it would be, I kind of didn't give you much time to look at it. Not bad. This file. Blinker SCH-1. So once that's opened up, project files opened up, schematic editor opened up, will be here. Now, the reason I created a stopping point here is mainly because it's unfinished. We need to make sure to add in the values for each component, as well as the reference designator. So we can start with values. This is sort of where we look at the properties for each component. When you right-click a selected component, it'll have a properties menu here. And when you open that up, you'll be given a table with a whole bunch of stuff. The top row here is your reference designator. If you read through the best practice sheet, I talked a bit about it in there, covering the reason why we have them and why they're a bit important. They're basically the unique number to each component, so you can identify them across schematics as well as in the bill of materials. We'll assign a value to that later on, because there's a way to automatically do it. Now you can manually do it just by typing in the number, but I'll keep that as is for now. Instead, we're going to look at the values. So the values should be the easiest thing to enter into this table, since when you're designing a circuit, you'll know the value. And so with that said, I'll look at the schematic here that we have. This is the more repetitive part of circuit design, especially if you have a lot of the same value component. All of these, the 4 on each side, 4 resistors, they're all 470 ohm resistors. So I'll quickly enter those in. And just a note on this, once again in the best practice document, I covered a point on SI prefixes and suffixes to values, especially resistor values. When we look at schematics, we don't use the ohm symbol, and there's an obvious reason for that. The ohm symbol could look like a 0, especially if you have poor eyesight or you repeatedly reproduce that circuit through screenshots or whatever else. So instead we use characters such as R, or in some cases E is being used as well. R is the most common. So in this case it would be 470 R for ohms. If you have a 4.7 ohm resistor, we would actually put the R in place of the decimal point for the same reason. The decimal point could degrade over repetitive screenshotting or printing and scanning, vice versa. But in this case, we don't need to do that. It's just 470 R. And then from there on, you just press OK. It sets the value right there. Click on the next one. To get into the properties menu a lot quicker, just press E. It should open that up right away. You just put that in. I'm just going to copy that so I can paste it in. Okay, press OK every time. And we'll these two middle resistors as is for now. We were going to give those a different value.
Yeah. Oh.
Yeah. And I'll give you guys a little bit of time. Any questions?
Is there any sort of shortcut where you can copy the value of one component and apply it to the next one?
Well, another thing you could do, and this is something I sort of employ if I already know the circuit beforehand and I'm designing it to make it look nicer, is a lot of the times I actually say I know all 4 of these or all 8 of these resistors are the same. I would go into here, fill out all the information, including the footprint and the datasheet link, especially if they're the same component. And then what I would do is I would just duplicate it continuously over, just like that. So that is one thing you can do. If you're designing the circuit kind of conceptually for the first time in KiCad, you can't really do that, of course, but if you know what it looks like beforehand, then this is a much quicker way of doing it. Yeah. And for the 2 middle resistors here, we've got 2 22 kilo ohm resistors, and you can see here again, the K is in place of the 3 zeros to indicate that it's higher value, higher order there. So when we go in here, I'm just going to go 22K, okay, and the same thing. So that's all the resistors, and the diodes don't need to be adjusted, the LEDs I mean. They sort of already have a value, LED. You could change that to name the diode part number if you want, or name the color or whatever purpose the LED serves. That's up to you. Yeah, so we'll leave those the same for now. The capacitors, those are going to be 10 microfarads. Now the mu symbol, in electronics we replace that with the U, the letter U undercase, mainly because not all type fonts have the mu symbol. So in this case, 10 microfarads, just like that, and same thing over here. In the document, in the best practice document, I also talked about text placement of the value and reference designator. You can adjust that to make sure it's near the component, clear, and well, simplicity is key. You want to make sure there's not too much information, it's not all over the place, whatever else. So in this case, I have it beside the capacitor on each side. You could also have it above and below the capacitor if you want. Both methods are in play. As long as it's not like all the way over here. And then I guess the transistors and the diodes here. We'll get into part sourcing to figure these ones out, especially the diodes and transistors. To get the value for these, I usually put in the value here, I put the part number of the component, or a shortened version of it, because some part numbers can get long. And then when we look at the data sheet, we'll get the footprint and paste the data sheet link in here. So that will kind of give us a segue into sourcing parts. In North America, we've got DigiKey and Mauser, and then there's of course local sourcing companies as well. DigiKey is the biggest one. I utilize it all the time. Companies around here, manufacturing companies utilize it. Everyone does. So we'll look at sourcing components from DigiKey. And you can follow along with this if you want to. We're going to go to the DigiKey website. There it is. Now when we go there, we'll be given the home page, of course. And from here you can search up the component keyword. Like say I'm looking for a LED. Throw an LED there, hit enter. And it gives you all of the options that you're provided. Now, you've got discrete and whatever else. We're gonna go with discrete. Usually what discrete means in electronics is like a single transistor or a single component, that type of thing. So if we go in here, we'll find that. And if you are on this page, you're doing great. So, from here, this is where things get a bit daunting. You're given a lot of options. And this, you'll know what options you need for the most part based on what you're designing and what you actually kind of can imagine it will look like. In our case, if we go to the schematic we're looking at, we're going to want this all to be on one PCB as a badge that you could wear or put on something. So we don't want any through-hole components that stick off the board really a lot. So in this case, we'll go with surface mount components. So that narrows down the search quite a bit. You just have to find the right box to do that. Mounting type, here we go. So surface mount, we'll select that. And that'll give us one filter. Now, it won't filter the results down here until you hit apply all, but we'll want to continue looking for more options. In terms of the LEDs, they're red, so you could select the wavelength of the diode. Wavelength kind of relating to the light and the color of the light emitted. And it even tells you, so there's that. I go to a longer wavelength. Red is typically a longer wavelength. 600 something, yeah. Got amber, red. Maybe. You can alternatively look for any LED type you want. So there's that. I think some of the part numbers do have the color in there, so actually, I don't know if we'll put wavelength there. Instead, I'm looking for package type. So package. A bit on packages. When you see a component on a board, there's different styles, different shapes and sizes and all that. You can get really small surface mount components. So how do we differentiate that? A really arbitrary component naming scheme that, you know, has no written standard for it. It all depends on the manufacturer. So there is documentation, and I haven't made a document on generalizing what these packages are, but that is a plan in the future. In the meantime, we can look at what looks good, I guess. Alternatively, you could just look at the images and hope that that's what you'll be getting. And I'm gonna hit apply all with the one filter that we set, and I guess we could just look from there. Might take a little bit. There we go. Okay. So we're already given quite a few, and I'm just gonna click on the first red one I see, which is this guy. So when you find something you like, check the quantity, make sure that there is enough in stock that when you order however much, you're not running dry. The price you'll be looking at to kind of price out parts is usually this price on the top, the cut tape price. Unless you plan on buying the 5,000, 10,000 part roll, this is the best price you'll get. And when we click on that, we'll feed in the product information. So, yeah, in here, discrete 2-volt. This here is your package, 0603. In this case, it's actually quite a small one. I should have had documentation for the packages level. If you open up the data sheet, though, it should have that in there. I'm going to look for an 0805 package, so it's easier to solder. But this is your 0604 package. It gives you the measurements on the data sheet usually. In this case, they are very small, less than a millimeter wide. So there is that. And in here, you'll be given all the data that you need for understanding what this part does, as well as how to integrate it into your circuit. But that's not the part we want because the package size is too small. I want a larger package size so it's easier to solder to the board. That's the main reason. So here's the next one. That one looks a little bit tiny. Ah, 0805. Okay, so this is a bit larger than the 0604. An 0805 package is kind of right on the edge of being easy to solder by hand. So, yeah, let's look at this. Open up the data sheet. I'll close the other one. All right, so here's the data sheet. Every data sheet will have its own sort of layout based on manufacturer. But yeah, you're given maximum ratings and everything else. And I believe at the bottom it'll show you the graphical data as well as the package size. Yeah. And it also gives you the recommended footprint for your PCB so you can solder it to the board correctly. And so on and so forth. Packaging information, labeling information, it gives you everything. So, say we want to use this part for our project. We looked at the data sheet, we say it's good, it'll fit our application, and it'll work. Maybe you ordered a sample and build a prototype and it works. Either way, what I do is I select the link to the file. In this case, it downloaded it for me, so there's that. But other PDFs, other data sheets, it'll be a link to the company website with it on there. Either way, if you grab that link and you put it into the component, I'll go here and edit it, and I'll just paste the link. That's added. You don't need to add the datasheet link if you don't want to. It helps, especially a year later when you're opening up this project and you're like, hey, what's that part? And this is the reason why, because if I click this component and press D, it'll open up the file, just like that. Super helpful shortcut. That's why I always add the datasheet to the part. In terms of the value, I'm going to set that to the, oh wait, that's a transistor. I'm looking at an LED. My bad. I want to edit this guy. Okay, LED. Now the part number for the LED, I can keep that as LED or I can put the part number in there. This case, I'll throw the part number in there. And the rest is doing that, copying it across all the LEDs, which is not fun. Before we do that though, I'll get into footprints. So I think everyone's clicking away at the other stuff. I'll wait a little bit and then I'll cover footprints. So footprints. Now footprints are what are the actual pad on your PCB. That's what it'll look like. For an LED, we've got the footprint 0805. If I recall correctly, that means it's 0.8 by 0.5 millimeters for dimensions. And you can find that, I think if we just search, no, that didn't work. If you go through, there's a lot of libraries. Think of these as folders, and then these as your footprints. We're just gonna go look through for LEDs, LED, SMD, SMD being surface mount, and THT being through. And we will look for LED 0805. I'm just going to search up 0805, and we're given these here. You're given two options here as well. You're just given the plain old 0805 package or footprint. Or there's another package that has kind of an extended pad, so it's easier to solder by hand. I'm going to go with this one. You can go with either of the two based on what you want to do. You just double click that and it adds it into the footprint box there, and once you do that you just press OK and that LED is set. And actually this is the issue with longer part names. They kind of get smushed with everything, so I'm going to set that back to LED. Now we have a lot of information in here. And there's a lot of ways to get that to all the other similar components.
Yeah, how do you get the footprint?
The footprint? Yeah, I'll go through that again. So to get the footprint, I opened up, I guess I glossed over that. You want to click on these three bars here.
Okay.
That'll open up your library window.
Okay.
And then from there, you want to look through all of your libraries so that you get your parts. So to find the library, it's easy to just search up LED and you'll be given two options. And when we do the transistor, you can search up transistors are different actually, the SOT, but I'll get into that after. Anyway, once you search up LED and go to SMD, we can go over here to get the package type, which is 0805. We'll get that there. And if you're unsure of the package type, it'll be defined in the data sheet and also on the product page that you're ordering from. So yeah. And then you double click that to import it into the footprint box. We're all good with that. Anyway, so going from there, there's multiple ways to get that information to each of these other LEDs. One that I typically use, if I have all the LEDs in there and I don't want to copy paste the LED symbol, is I'll just select these boxes here that I've changed, copy them, and then I'll go to the next LED, click on the top leftmost box and paste, and it'll paste all the information in. Additionally, if you want to, you can delete the other ones and copy and duplicate. Copy, paste, and you can add those in just like that, and they should have the same information on them. So we did the LEDs. I'm gonna save the more challenging one last, which are the transistors. Let's do the capacitors. Oh, yeah, and we need to do the resistors. So the capacitors, unlike the LEDs, they won't light up, but we're gonna use the same package. So we're gonna look for an 0805 package on DigiKey for a capacitor. Oh, I forgot to mention too, when you do have, like for me, what I do typically is I will add extra fields in the properties menu here. You can add as many as you want. You can also delete as many as you want. I usually add in DigiKey part to add the part number so that I can easily find it on DigiKey if I want to. And this value also gets exported into the bill of materials when you do go to export the bill of materials. It helps out. You can add it if you want. If you're trying to do a quick design, it doesn't matter. Right now I won't because that'll take up a bit of time. But that is an option. Anyway, going to the capacitors, I'm going to look for a data sheet, or I'm going to look for a part, put in the data sheet, and find the footprint for it. So in this case, let's search up capacitor. I'm going to go with the ceramic capacitor because it's not polarized. And you'll be given roughly the same filter boxes. I'm only going to select 2 filter boxes here. I'm going to look for package / case. I'm going to go through here and I'm going to look for an 0805. And I'm going to select that. And then I'm also going to look for the value that I want. So you can go over to capacitance here, and you can search up a range of capacitances to search from. In this case, I'm just gonna select one. Where did you go? There we go. Max, I'm gonna set as 10. Minimum, that's not. Minimum, I'm gonna set to 10 as well. And that'll just give me a 10. It'll stop flying over to the other side. Just gotta scroll through. I guess it didn't highlight it. UI can't get it in like, filter doesn't seem to be one for it. Yeah. It's usually sorted by value, so you can scroll through as well. If, like right now, the min-max search doesn't want to cooperate. And this should give us pretty much what we need. You can also, if you have an application where you need to specify the rated voltage or any other parameter for your project, the filter is there. I'm going to hit apply with those 2 filters. And they'll be given a nice list of capacitors. They should all be an 0805 package at 10 microfarads. So I'm just going to select the first one I see, which is this guy here, made by Samsung. Looks good, plus minus 10%. And I'm going to look at the data sheet here. And as you can see here, this one is posted to DigiKey, so you will be able to paste that one into the data sheet box on your schematic. And on the data sheet here, it gives you, once again, labeling information, packaging information, information on the component, its maximum ratings, and so on and so forth. We know it's an 0805 package, so we're good there. And yeah. So I'm going to go back and I'm going to put in the link to the data sheet. And then the footprint, once again, is, you'll hear this a lot from me today, is an 0805 package. I'm going to search up capacitor, SMD, open up that, and search up the footprint.
And
Double click that, and it's in there. So I'll let you guys work away with that. And then of course you can select the 3 rows to copy it over to the other component as well, the other capacitor. Just like this. Then you can also test to make sure the link to your capacitor works by hitting D and going up. Yeah,
Sorry, which footprint did you use for that?
an 0805.
Okay.
Yeah, so I think most of the components here, including the resistors, will be a 0805 package. Depending on the component you use, like the LEDs here, when we searched up that, it had LED_0805. And then if we go over to the capacitor here, it's going to be capacitor 0805. I don't think it matters too much. It's just they organized it that way. Yeah.
Sorry, so I was looking at the DigiKey part number, there's apparently 3 of them for the passage shows. Is there a difference between them, or do I need to just pick one?
Well, you can get into quite detail, like you can get into detail in finding components. There's a lot of parameters with components, whether it be resistors, capacitors, inductors, transistors, whole shebang. In this case, our application doesn't have any specific requirements for components, so you could pretty much use any off-the-shelf component to fit the function, and that's why I chose the top component there.
Right, yeah.
But say I'm working on building a radio, and I need a capacitor that has a very, very, very small temperature coefficient. So that means it doesn't change its value based on temperature. Then I would do an extra filter to find an NP0 rated capacitor. You can get into quite a lot of detail with that.
But like the Chinese government.
Yeah.
It's the one you showed us.
Yeah.
Remember you put an extra field for the DigiKey part number?
Yeah.
See that there's like 3 of them on that page?
So the DigiKey, on DigiKey, and actually thanks for clarifying that, I'm gonna revise one of my documents now that you mentioned that. On DigiKey, you're given multiple part numbers. And this has to do with the way that it's packaged. Whether it's on a small piece of just paper, cut tape, it's got little components in it. Or, in this case, you can get a tape and reel would be, I actually don't know, I think it's just the line. Oh yeah, it's a small reel with all the components wrapped around on a little paper or plastic roll or strip. Digi-reel, these ones are the larger quantities. And then of course cut tape is the smaller quantities. You get a small strip and 10, 20 components, that type of thing. So yeah, those part numbers in here, these are just for DigiKey. So if you order from Mauser, they've got their own system, and vice versa. Yeah. Now there are manufacturer product numbers here, and like we saw on the data sheet here, I think it teaches you how to read it because they do get quite long. So yeah, and every manufacturer has their own system, which helps a lot. Not. Yeah. Anyway, so we've added in the footprint and the data sheet, and now we can move on to the easier component, resistors. It's the same process as a capacitor. We go and look for a resistor. Search that up. And we're going to go with a chip resistor, surface mount. And once again, filters. So the filters we're looking for is the same as the capacitor. I'm going to go to package case. I'm going to search up 0805 and search up, yeah, it's right here. Now keep in mind, there are metric measurements as well. 0805 is the imperial, so the 08 means 0.08 of an inch long, and the 05 is 0.08 or 0.5 of an inch in width. And in metric, that would be like 0.2 or 2 millimeters, one or the other. 2 millimeters and then 1.2 millimeters wide. So that's sort of the system. Different packages have different systems. Select that guy. Yeah, so you don't want to end up with a 03, 02 package, because those are things you find on your phone motherboard. Super tiny components. I don't think you can solder those by hand, at least not without a microscope. And then for value, I'm not going to bother with that. I'm just going to scroll through and look for, in this case, we want 470 ohms. So I'm going to select, scroll through real quick, yeah, 470 ohms. So select that, and I'm going to hit apply all. And in there, we will be given, once again, a nice list. I'm going to go with the top one. Actually, this one has more in stock, why not? Let's go with this one. As you can see, these components are actually quite cheap as well. Resistors are dirt cheap. I did not want to do that. Yeah, so you can order quite a lot of these, burn them if you want, whatever else. Yeah, so I'm just going to go with this part here. Open that up. Once again, we have product page. We open up the data sheet. I'm going to copy the data sheet link while we're doing that. And here you can see all the data on the part, and I think multiple part numbers here as well. Some data sheets will be a data sheet for a whole group of parts. So there's that. And in here you can once again get package information, width, length, thickness of the component, and all of the other information. And if you want something to put you to sleep, you could read through the whole thing. I usually just go in there to look for one bit of information. Anyway, so now that we know the part, I'm going to once again go back, fill in the information. Data sheet can go there, the footprint. Once again, a 0805. I'm going to search up resistor here, because may as well stay consistent with the libraries. And you can search up 0805 and select the hand solder one if you want. And then that will set the footprint for this component. Now, if you're creating a schematic and you forget to set a footprint, when you import your schematic to the PCB layout editor, it'll throw you errors and it'll tell you what reference designator is missing that footprint. So it helps to remember to put in all the footprints the first time around, but for large projects, you'll miss a few. So there's that. And then, yeah, once again, copy that and add it to the other components. In this case, I'm just going to do this method. Just for time's sake. So now all these should have the proper data. And then these resistors in the middle, the exact same process. Search, filter, find a component. In this case, just at a glance from the part number, I know exactly what to find. Search for it or not, actually. No, that's how that works. That is is a 220K. I think it's easy just to search from here. Every part number has a different system. And then to cancel your filters, you just press X or remove all. And to reset your filters. Package.
Yes.
Okay, need a consistent. Okay, and I apply, and it's good to keep for resistors, maybe capacitors and inductors. It's good to kind of maintain consistency throughout manufacturers we order from. So since we ordered from, I guess this would be stacked pole. Okay, let's find a stacked pole electronics resistor. You can search up manufacturers here, right there. Let's apply that, and then we'll be able to keep the resistors relatively the same. It doesn't matter entirely. Consistency is key. Yeah, that's just one character out on that search. So, yeah. Once again, data sheet. This data sheet is the exact same as the other one, just because this is in the same family of resistors. And once again, paste that on in there. Data sheet and footprint, once again, 0805. And hit OK on that, and then of course, copy the value on over. This is the more repetitive part of schematic design. You learn to love it. But sourcing parts is the best thing ever too. Hey, you gotta read the data sheets to make sure that they are they have the specs that you want. So yeah, and now I saved the harder thing for last. That being these two transistors. And also with the transistors, we need to once again make sure that the pin numbers are correct. I put down a VEC, base emitter collector pin order on these ones, but the part I find might be different, so I might have to change the footprint or the symbol in the schematic to accommodate that. So we'll see how it goes. To find transistors, like all the other components, you search it up, and you can get the through-hole stuff, you can get the surface mount, or even arrays, which are basically in one chip that's got multiple different transistors. We're going to look for single transistors here, and we're going to find a transistor in the package of SOT23. You learn the packages over time. The more you use them, look at other schematics and circuits and whatever else. And there's also good documentation that covers which packages are good for which applications. An SOT package, small outline transistor, that's what the acronym is good for most things. And in this case, we're doing SOT 23-3 with flat leads. The flat leads means that the pins coming off of the chip are kind of going down as flat to the board. And that is pretty much all we need. I'm gonna select NPN here. And there is a difference between a Darlington and a normal NPN. So we're gonna select NPN here. And I'm gonna hit apply. Now we're given a few options, of which I actually don't know the characteristics of, but we can take a look. In this case, this one's a 400 volt, 500 milliamp. It's got high speed and can handle a lot of heat. I am going to do that. I'm gonna go search up a component that I know of. It's very common, a 3904. This is the transistor I designed this circuit around. That is not a transistor. And whenever you search in the search box there, it'll usually apply to the main list, so you can narrow things down that way. There we go. These are the parts I remember. Okay, these transistors are very cheap as well. I'm going to select this guy here. It's got 5 million in stock. And I'm going to look at the data sheet to get the pin out. Now this is where looking at the data sheet really matters, to make sure that the pin out here is correct. So this is kind of this is your 3D view of what the component will look like. You've got your symbol, and then your top view and whatever else. And all the information for the transistors in here, maximum ratings, whatever else. And this is your package dimensions, and so on. So yeah, if you have like in KiCad, say you have a footprint that you don't have in KiCad, the data sheet will have the information there in which you can make and design the footprint in the footprint editor. Most footprints are in KiCad that you'll see. So it is not common that you'll need to use it. But you can see here, we've got a collector-based emitter layout. So we're going to want pin 1 to be on the collector, pin 2 on the base, pin 3 on the emitter. And in this case, I think we've got it not quite there yet. So we're going to have to change out the symbol. So this is a nice pin numbers, base, collector, emitter. You want to make sure you get the pin numbers on the package as well. That way you don't screw that up. So I'm going to look it up. Just to make sure. Yeah. Okay. So on an SOT23 package, you go 2 pin side first from the top, 1, 2, 3. So on our data sheet here, 1, 2, 3, base, emitter, collector. Okay, cool. So we do have the right symbol. We have base, emitter, collector here. And this is what I mean by you gotta be a little diligent with that, because the data sheet might not give you all the details you need. Yeah, sort of the make your measurements twice, not once type of mentality. You want to make sure you order the PCB with the right footprint and pin numbers. Otherwise, you have what I went through last year for the same workshop. Because we ordered PCBs with the wrong pin outs on these transistors. That was a whole panic. Luckily, they didn't make the full batch, so we were able to contact the manufacturer before they shipped them out. So, yeah, now that we've found the transistor that we want, I'm gonna, once again, copy the link to the datasheet, edit that, put it in. The value, in this case, I will, for transistors and ICs, you do want to put the part number in there. So I'm gonna find the part number on the datasheet, copy that, and throw it in there. And the footprint, like before, different from an 0805, because this is a 3-pin component now. I'm gonna look up transistor. Nope, not there, okay. This is an NPN. Nope, okay. SOT. There we go. So, TO, SOT, SMD packages. This is sort of a family of different packages. They all have different sizes. Kind of, if I go through here, you can see the various. There's a lot of packages in that family. This is the guy we're looking for though. It's SOT-23. There's also a 5-pin variant, a 6-pin variant, and so on. But in our case, there's a hand soldering version too. Didn't know that, I think. I have that on the other version as well. And we're just gonna select that footprint. And yeah, and that's all there is to finding transistors. The same process, the process is the same for pretty much all components. So there's that. Any questions? We're all good? Okay. So, yeah, and once again, since we have two of these parts and they're identical, I'm just gonna copy these, paste it over, and hit OK on that. Okay, so we're almost there. The battery, this one is one of those situations where I could not find the footprint in the library on KiCad for this part. It's a battery bracket, so they're a bit more, they're a bit less common. Especially the one I ordered wasn't, it was sort of a one-off type of order. So I had to make a footprint for it. And I'll save you guys the pain, but I'll quickly show you how. Now, I made a custom library. You will see it on here, assuming you opened up the Blinker Schematic -1. The library has a really creative name. Library. You'll find it under L, right under LE, or you can search for it. That works too. It'll be there. And in this library, I have all of the footprints and whatever else that we're using in this project. You want this guy, the CR2032 battery holder. And I'm going to select that and put that in the footprint. I don't have data sheet for the bracket, so we'll leave that blank. And I will hit OK. So just for clarification here, I found the library, and then I grabbed this footprint here. And double click that, and then hit OK. So with that done, all components should have a value, footprint, and data sheet link. Yeah.
Sorry, so what happens, I mean, it was supposed to be Blinker Schematic 0, right? The one we're doing right now, because I don't find library.
Yeah, because the Blinker Schematic 0 doesn't have libraries. So it's the Blinker Schematic -1 that has library. No, in your case, I will save you the pain of having to redo all the work we did. In the file directories, when you have that, if you go here,
Yep.
you don't have the library file.
Yeah.
But if you go here, this is the library
I
file.
just copy over.
You'd want to do that plus these FP- files.
Okay, got it.
So when you copy that over to the other folder, restart your project and it should recognize it.
Got it.
And yeah. Anyway, so that is that. Going back to KiCad here, that's pretty much all the values. Actually, you might not even have to do that. I saw someone else had a question. Yeah. Oh, it was the same question. Okay. Yeah. So for those of you who don't have the library, it's in the SCH-1 folder. You can copy the library.pretty folder as well as the files that have FP- at the start. Those are, that's how you copy over libraries. And you need, if KiCad doesn't recognize it, the easiest way would just be to open up the next stage here. Yeah, question?
Can you show how to do the library thing one more time? Where you get,
Oh yeah.
if you don't have it?
Yeah, so if you don't have, actually I'll save everyone time. Yeah, if you don't have the library, you just copy over those files. This is the library table, info cache, and another template here, plus the main library. That's what you transfer over. Instead, what I'll have you guys do is, since we completed filling in the information and sourcing parts, what I'll have you guys do is reopen up Blinker Schematic -2, since we are already at this stage. So I'm going to close out of this real quick. And I'm going to open up this folder here. So this one will have a lot more in the folder. If you double click on the project file, I don't even think I curated this one. I think it's got the whole thing on there. Open up the schematic, and all of the values should be in there, including the reference designators. That's what I forgot, reference designators. Okay. So, for reference designators, you can enter them in manually. That's one trick. That gets tedious, especially with large circuits. So they have in KiCad, they've got an automatic way of doing it. So I'm just going to switch some of these back to question marks, just to show that it works, even if you have some reference designators and a few others that aren't set, right? So if these designators weren't set, including this transistor, and say this battery doesn't have a reference designator here. So if those aren't set, and we need to set or reset the reference designators, what we can do is we can hit this button up here, fill in schematic symbol reference designators, and it automatically goes around in a preset path, which you can select here. It'll go through the circuit and set all of the reference designators. This is entirely by preference, which order you use. I usually go by X position, that way smaller values are at the start of the signal path, larger designators are at the end. And we go over the entire schematic, we can go over the current sheet, everything else. I'm going to press annotate, and you can see it annotated the ones that didn't have designators. And just like that, we have all of the designators set. You will want to have all the designators set. I believe it throws an error if you try and import your parts into the schematic editor, if you don't. And yeah. So, and the reason I wanted you guys to open up the SCH-2 folder is because all the information is in there, plus a bit more. I also included the DigiKey part and link to the part that we've got in there. So these ones are a little bit different from what we searched up, but yeah, they should it's generally the same. Don't know why that's there. Here's a quick tip while I'm here. If you want to show the pin numbers on, say, an LED or any other part, just check that box, and it'll show the numbers on the pins. I do that for the LEDs because surface mount LEDs aren't quite easy to tell which direction you solder them in on. They don't have a line on them, they don't have a longer lead because they don't have leads. So, depending on the part you order, it'll have a green or another colored triangle on the bottom of the part to tell you which direction conventional current will flow. Consult the data sheet. That's all I can say. Anyway, so we've got all the parts in here, all the footprints. You can check the footprints. It's got DigiKey part, DigiKey link, everything else. Once we're at this stage, we're going to want to create our bill of materials. The reason we want to create a bill of materials, it's a nice list of the parts we need. It's good to keep track of and helps us order them as well. And also, if you're having troubles, you don't have the schematic with you, but you have the bill of materials, and you're looking at the PCB, it's like, oh, what's R5? Look at the bill of materials, R5, cool. It's 22K ohm resistor. So that's another reason for a bill of materials. And to do that, KiCad does it for you. You just go up to this little button here, bill of materials. If you click that, you can get the bill of materials grouped by value, and it includes the footprint on there if you want. Or you can just have it without the footprint, all the other information's there. And yeah, so we'll do that. I'm gonna hit generate. And what that'll do is it'll create a comma separated value document inside the project folder. Here, through me success. So if we check the folder, the CSV file should be there and it should be updated, so we can open that. You don't have to. I'm just going to double check to make sure that you're ready. And just like that, this is what it'll look like. Hey. I have opened Excel. So, a CSV file is a bit different from an Excel file. You can't really format it, and it doesn't save formatting. So there's that, and I actually think Excel won't want me to do anything because I haven't restarted it, but generally this is what your bill of materials will look like. The most important information here is the collated components. It'll just give you the quantity for each component. This is good for when you order. And this is also the reason I have DigiKey part and DigiKey link, because you can throw all of these parts into your cart while ordering from DigiKey, and it'll find all the parts for you and put it in your cart. I actually wrote a document I forgot to mention. There is a document in your guys' folders that goes through ordering parts as well as ordering PCBs. So here we've got part sourcing. It'll just run you through an example for both DigiKey as well as Mauser. Mauser's layout is generally the exact same as DigiKey. Very, very few differences. So I'm not going to bother going through that. But the document is here, especially for reference if you ever forget. Yeah, that is EW23-03. Anyway, going back. With the bill of materials created, yeah, I think that's pretty much time. We were able to get through this session quite quickly. So now that that's created, this is where we would start with the PCB layout and start designing that, I guess. We have about 10 minutes left. PCB stuff would be a bit crazy to get into in only 10 minutes. So I think we can call it there. Yeah, questions?
Did we have to find a data sheet for the battery as well?
Like the battery we use, I was talking about the bracket. The type of battery you use, it doesn't matter. I mean, it could be a AA or a AAA. The part that we're finding, that one's going to be kind of like the little connector for the battery to plug the battery in. And that could be different. I think I've got the data sheet on here. Yeah, I do. So you could, if you want to, you don't have to put in the data sheets for any of these components. This is just a time-saving technique. especially in CAD, it has a function where if you press T, it'll open up the data sheet for it. There's that.